Okay, this is another Mad Forest problem. This time a student is standing on a bathroom scale in an elevator at rest. So let's just look right here and figure out what's going on. Here's your person. It's a student. He's standing on a scale. He has force of gravity. And that would be mass times gravity. We don't know what the mass is. But we do know force normal. Force normal is what the spring scale reads. That's what the spring scale reads. When not moving. Okay, so force net. Force net will equal 0. We're not moving, we're not moving, we're not moving. So the acceleration is 0. So forces add all up to 0. And what are the two forces? Force normal plus a negative the force of gravity. This equals 0. So force normal is equal to the force of gravity. And I'm telling you that that is equal to 836 newtons. What do we also know about the force of gravity? This is equal to mg. We don't know that. Look for this. We already know that. So, force of gravity is equal to mg. We can say 836 newtons is equal to mass times 9.8 meters per second squared. Divide by 9.8. Divide by 9.8 meters per second squared. Meters per second squared. And these cancel out. Mass is now equal to 85.3 kilograms. Voila, that's important information. We're going to need that later. There is the start to get to A. All right, I have to erase all this, but I want you to remember that mass is 85.3 kilograms. That's how you find it. I've got to erase all this and get me some more room. All right, I'm really going to give up here, so. All right, continuing. This is number A. Now, A says the elevator is moving up. So here's your floor of your elevator. This is the floor. And we are going to be we're moving up. Our A is going up. So we have a feeling that is occurring in our body as we're accelerating up. Because the floor is pushing up on us, we're actually going to feel heavier. So I'm going to feel heavier. Just gain some weight. That's what's going to happen. We're going to feel heavier because the floor is pushing us up even more. But what do we actually kind of know? And we look at our information about the sum of the forces, all out of your forces up, and we're going to put accelerating upwards. All right, but now we say that the floor increases, so now we're weighing more. So that's how come I know I'm going up, all right? We're weighing more. What are the two forces acting on my human body? Well, I'm going to have normal force. That's a little fluctuating. Normally it stays consistent, but we're in an elevator. Plus, minus the force of gravity. That's your weight that we found, or actually was given to us. And then this human body's mass we found was 85.3 kilograms. We found that already. Is going to accelerate. And we're trying to find A. What is A? What is this A? Well, we know all the information. It's practically given to us. This was 336 newtons because we read it. Bam, right there. Plus negative the weight when we're just normally standing on the ground. And that's equal to 85.3 kilograms times A. Divide by 85.3 kilograms, both sides. 85.3 kilograms, both sides. Don't forget, this has got to get this one number first. Hopefully plug into your calculator correctly, and you should get A is equal to 100 newtons divided by 85.3 kilograms, 1.17 meters per second squared, going up. It's like magic. The board erased instantaneously. All right, now we're going to do B. Now we're going to be doing the floor is now going to go down. The floor, I don't know what's going on. So the floor is going to be going down. We're like starting to feel lighter. The floor is dropping away. Dropping away. So this is my rapid weight loss. Weight is less. Yay! Okay, so what did I start weighing? There you go. All right, but I still have the same forces idea. So when I'm working with B, I still use this equation right here. Well, what are my forces? Force normal from the elevator floor plus a negative force of gravity, but this time my MA, this is going down. So I want to make sure that I have a negative sign. I want to be looking for my A to show me that I'm going to weigh less. Well, let's put in for what we know. My normal force, which was already given, is right here. 782 newtons plus what I normally weigh, which is negative 836 newtons, plus my mass, which is 85.3 kilograms, times A. Divide by 85.3 kilograms, bam, divide by 85.3 kilograms. These units cancel out. Alright, final answer. I get A is equal to negative 0.63 meters per second squared. And where did I get the negative from? Because I don't want to forget that. Oh, that just all this means with a negative here just means going down, going or accelerating. There you go. There you go.